A very good morning, children. Welcome back to the last session of the first chapter, Force and Pressure. We are all surrounded from air from all the directions. This envelope of air around us, we call it as atmosphere. Does air also exert pressure on objects on the earth? Liquids exerts pressure in all directions. Like liquids, air also exerts pressure. Air is pulled down by the Earth's gravitational force. This force applies pressure on the air in the downward direction. The pressure exerted by air is called air pressure or atmospheric pressure. You already know that atmosphere is divided into different layers, namely troposphere, stratosphere, mesosphere, thermosphere and exosphere. Pressure in the bottommost layer, that is troposphere, is higher than the pressure of the layers above it. This is because the weight of air above the troposphere is more than the weight of the air above the stratosphere. Air pressure acts in all the directions, not only in the downward direction. So, like the pressure in liquids, the air pressure at a particular height above the Earth's surface is same in all the directions. That is, if I consider these 2 points at the same distance above the Earth's surface, then the air at this point exerts an equal pressure in all the directions, just like the air at this point. Let's look into the interesting graph now, children. The graph representing the pressure at a particular altitude. Here I have expressed the altitude with the unit of kilometer and the pressure with millibar. Okay, bar is nothing but it is a unit to represent the pressure. The graph also represents how the pressure varies from layers to layers. Here I have mentioned the layers, children: troposphere, stratosphere, mesosphere, thermosphere and exosphere. This graph also represents how the pressure varies from layer to layer. The troposphere is the closest to the surface of the earth. That is to say, the pressure in this area goes up to 1 lakh Pascal. That means this is the massive pressure, children. This pressure pushes and pulls the objects on the surface of the earth. So, Pascal is also one of the unit, that is SI unit, to represent the pressure. Now, for example, if I consider a table with the measurement of 1 meter length and 1 meter breadth, then the pressure exerted by air in the downward direction to the table is greater than 1 lakh Pascal. That is to say, this is equivalent to the 10 cars being put on this table. I know what you must be thinking. Why doesn't the surface of the table collapse under this huge pressure? How does table manages such massive pressure acting down on it? A little while ago, we said the pressure exerted at the points above the Earth's surface is equal in all directions. So, the pressure at every point on the table is same. If I consider the table, the pressure is acting in all the directions. So, the pressure is acting in all the directions are the same. If the downward pressure F1, which is acting on the table surface with a greater force, then the upward pressure, that is F2, is also pushing the table in the upward direction with the same force. Both the forces are balanced, that is to say F1 is equal to F2, and the table does not collapse. As I've said, the pressure is not only acting in the directions of F1 and F2 but also acting on the surface in all the directions. Therefore, pressure acting in the opposite directions cancel each other out. So therefore, what will be the net effect of pressure of air on the table? It will be 0. Let's look into another interesting example, children. So which you can also try it at home. What you need to do is take a plastic bottle, fill it with water. After that, take a cardboard paper and place it on the open end of the bottle like this. Hold this paper with your hand so that it does not move from its position and then invert the bottle. Now, let go of the paper, children. What do you observe? Yes, the cardboard paper sticks to the surface, isn't it, of the plastic bottle. Why does it held to the surface? It's held to the surface because of air pressure. That is, air is pushing the paper in the upward direction. The upward air pressure is sufficient to encounter the downward push exerted by the water. Here, the air pressure is greater than the pressure exerted by water. Therefore, the cardboard sheet is not being detached. It will be stuck into the place of the water bottle. Now, let me make few holes in the bottle at this place, children. So what happens now? What did you observe, children? So you can observe that the water is coming out of the bottle. Afterwards, just observe where is the cardboard paper. Why did the paper fall off? Is the upward pressure stopped acting or did it reduced? As I've said, the air pressure was acting upward, isn't it? So whether that pressure stopped acting or reduced, the answer is no, it didn't. The upward pressure remains the same. That means the air is exerting the same amount of upward pressure, but the downward pressure is increased. Now the downward pressure exerted by water is greater than the upward pressure exerted by air. So, when we make the holes in the bottle, we allowed air to flow inside it from the top. The air from the top started exerting pressure on the water. That is, combined pressure of air and water can easily overcome the upward pressure exerted only by air. Hence, net force that is acting on the bottle is in the downward direction because the upward pressure is lesser than the downward pressure. Upward pressure is lesser than the downward pull. Therefore, so I can say this is the reason why the paper detaches from the surface of the bottle. I hope you have understood today's class that was mainly dealing with atmospheric pressure. So with the example, we understood about the atmospheric pressure and how the air exerts pressure in all the directions. So therefore, total pressure exerted by air in any object will be nullified. I hope you have understood the today's session, children. So we will meet again in the next week with a new chapter. Until then, thank you for watching the video. Have a good day, children. Stay at home and be safe.